Welcome back to the deep dive.
Great to be here.
Today, we are taking a plunge into something really fundamental. It affects everyone,
Absolutely. We're talking about the quality of scientific research.
especially in health and medicine, which is, so critical.
It's a topic you just can't ignore these days
Yeah,
with information spreading so fast.
exactly. And for this deep dive, we've got a few interesting sources lined up.
Mhm.
There's a report that outlines some, frankly, quite serious issues,
Right.
and a news piece from Nature that really highlights the problem, puts some numbers on it.
Some surprising numbers, actually.
Yeah. Plus a note about an organization called Zaiku and their Quantum Formalism Academy.
So, yeah, these sources together, they give us a really sharp focus on a worrying trend in scientific publishing right now.
So our mission today is to take what these sources tell us and really unpack it.
Figure out why we're seeing this flood of low-quality studies.
Exactly. And what does that actually mean for, the real world?
And are there any fixes? What can be done?
Right. This is all about helping you, our listener, understand what's going on behind the scenes in science publishing.
And why it really matters to you directly.
Right.
It's about the foundations of the info we all consume.
Okay, let's unpack this then. One of the core findings, it seems, across the board
Yeah.
is this pattern where they describe hundreds of studies seem to follow a template, reporting correlations between really complex health conditions and just single variables.
And what's striking there is, these conditions, things like depression or heart disease, we know they're incredibly complex. So many factors.
Genetic, environmental, lifestyle.
Right, all of that.
Yeah.
But these studies, they're sort of zeroing in, linking it all primarily to one thing.
Like vitamin D levels, maybe? Or how much sleep you got.
Exactly, those kinds of things. Just one isolated variable.
And the sources, they have a term for this, overclaiming.
Overclaiming, yeah.
Yeah.
Because they're taking these super intricate biological systems and just simplifying them down drastically, presenting this single link like it's the main story.
Maybe even implying it's cause and effect when it's just, a correlation that popped up.
Precisely. And a major reason this is happening, the Nature article really flags this.
What's that?
It's the sheer availability of these large public data sets.
Ah, okay.
They mentioned the U.S. National Health and Nutrition Examination Survey, NAATS.
Right, I've heard of that. Massive study, lots of data.
Exactly. And it's public, it's accessible, and maybe most importantly,
Easy to analyze.
easy to plug into standard analysis tools. That's the key.
Which seems to be fueling this huge surge in these specific kinds of papers.
Oh, definitely. The Nature article calls it a sudden explosion in publication rates.
Wow, do we have numbers on that?
We do. One source looking at PubMed data.
The big medical database.
Yeah. Found over 2,200 of these association studies using NAGNA's data published just in 2024.
2,200 in 1 year.
And get this, we're only partway through 2025. Over 1,200 have already appeared this year.
That's just an incredible volume.
It really is a massive output.
And our sources, they're pretty explicit linking this surge and the kind of formulaic nature of it all.
To AI.
Straight to AI. They describe the papers as so template-driven.
Like fill in the blanks.
Almost.
Yeah.
That they could easily have been generated by large language models.
Right. AI tools just make it super easy to process that available data and churn out these studies.
Which connects to another big issue they raise, right? This idea of cherry picking.
Yeah, exactly. There's a great analogy one expert used in the source material.
What's the analogy?
They said, imagine you're trying to pass an exam. You add as many questions as you want.
Okay.
You see which ones you got right, and you remove the ones that you got wrong. That's basically what they're doing.
So you run tons and tons of tests on the data.
Hundreds, maybe thousands of possible connections.
And you only report the ones that happen to cross that line for statistical significance.
Exactly. The ones where the math suggests it's probably not just random chance.
But if you run enough tests...
Something's bound to look significant just by chance alone.
Like throwing spaghetti at the wall, you said?
Yeah.
And only showing the bits that stuck.
That's a good way to put it. You only highlight the hits, ignore all the misses.
And, okay, maybe cherry picking isn't totally new.
No, it's been seen in other fields, sure. Chemistry, physics.
But the sources are saying now it's hitting medicine really hard.
Right. And as they point out, the consequences there are just far more serious.
Yeah, that makes sense. The potential for real harm seems much higher.
Definitely.
So the big question then is, why? Why is this happening?
Why is the system letting this happen?
Yeah, why is all this formulaic, potentially flawed research getting published, especially with such high stakes?
Well, the Zaiku report we looked at really tries to get at the systemic reasons.
Okay.
They point to a few key areas where the whole structure seems to be, well, failing.
Okay, let's dig into those. What's the first big one?
One critical issue they raise is low-quality peer review.
Ah, the traditional check.
Yeah. The system where other experts review a paper before it's published.
Yeah.
They say it just doesn't work well anymore for catching these kinds of issues consistently.
Like the formulaic stuff, the overclaiming.
Or the signs of cherry picking, yeah.
Yeah.
It seems like the sheer volume, maybe the specific nature of these data-heavy studies, it's overwhelming the process.
So reviewers might not have the time or maybe the specialized stat skills to spot it all.
That seems to be the implication. And then, tied to that is the second point, metric-centered recognition.
Meaning?
Meaning universities, funders, they reward researchers based on simple numbers, like how many papers did you publish?
Ah, the metrics. Quantity over quality.
Exactly. It creates this huge incentive to just churn out papers if you can generate lots of these formulaic ones easily.
It boosts your numbers, helps with grants, promotions.
Right, the classic publish or perish, but maybe on steroids now.
Wow. Okay, and the third factor, I think we touched on this.
Yeah, it's AI enabling mass production.
Right.
As we said, AI tools just make it incredibly fast and easy to generate these template papers.
So it feeds right into that quantity over quality problem.
Exactly. It's like pouring gasoline on the fire that the metric system already started.
Okay, this is where it gets really interesting and honestly pretty consuming.
The consequences.
Yeah. The sources detail several really serious consequences that flow from this flood of potentially low-quality studies, especially in health.
Yes. The Zaiku report outlines quite a few worrying impacts. One is on students.
How so?
Well, labs that are focused on just churning out papers using these formulaic methods. They might not be properly teaching their grad students how to do truly rigorous research. Designing solid experiments, deep critical analysis.
So they graduate without the core skills.
Potentially. And the report raises the question, will industry even want to hire them if they lack those fundamental research skills? It's a pipeline issue.
That's a really worrying thought for the future. What else?
Another big one relates directly to AI. Lots of people now, they turn to AI assistants for information, right? Even science-backed advice.
Sure.
But these AI tools, they learn from the published literature. If that literature pool is increasingly polluted with flawed or formulaic studies...
The AI can't tell the difference.
Exactly. It doesn't judge the quality or the rigor. It might just pull a conclusion from a dodgy, cherry-picked study and present it like it's solid fact.
Leading to widespread miseducation. Wow.
Yeah. The AI essentially reflects and amplifies the problems in the data it's trained on.
Okay, what's another consequence?
It also impacts experienced researchers. Think about supervisors, the PIs mentoring PhD students.
Yeah.
Students, naturally, they rely on published papers to start their work, but they often don't have the experience yet to spot a weak study from a strong one.
So the supervisors have to spend more time.
Exactly. More time just helping them wade through the noise to find reliable foundations for their own projects. It slows everything down.
Makes the whole standing on the shoulders of giants idea much harder if the shoulders are shaky.
Well put. And maybe the most serious consequence, the report really emphasizes this, is for doctors.
Uh-oh.
If medical professionals are trying to stay up to date, relying on the latest research to treat patients.
And they unknowingly use flawed studies.
The outcomes, the report says, will be disastrous.
That's where it hits home. Public health, patient safety.
Directly.
Okay, so it sounds pretty bleak, but surely there are ideas on how to fix this. Do the sources offer solutions?
They do. It's not all doom and gloom. The Zaiku report, in particular, lays out some potential ways forward.
Okay, good. Let's hear them. What's one?
One proposal is mandatory data submission.
Meaning?
Meaning when you submit your paper, you have to submit all the raw data that went into it.
Ah, radical transparency.
Kind of. It's not just so others can try to reproduce it. The idea is that maybe future analysis, perhaps even by smart AI,
could check the quality?
Could assess the quality of the interpretation, the conclusions drawn by the authors, not just take their summary results at face value.
Interesting. Okay, what else?
Another idea is stricter statistical rules.
How would that work?
More rigorous guidelines on how you apply statistics, how you report results. Maybe things like pre-registering your study plan.
So you can't just go fishing for results afterwards.
Exactly. Makes it much harder to cherry pick or sort of pack your way to significance.
Right. Closing those loopholes makes sense.
Then there's a bigger systemic idea.
Yeah.
Eliminate metrics from evaluation.
Get rid of the paper counts.
Basically, yes, stop evaluating researchers, grants, promotions based primarily on the number of publications.
And focus instead on
Quality, rigor, actual impact of the work. Remove that incentive for just churning things out.
That feels like it gets closer to the root cause.
It definitely targets the incentive structure. And one more suggestion.
Yeah.
Using AI for pre-peer review.
Using AI to fight AI-enabled junk.
Sort of.
Yeah.
Journals could use AI tools as a first pass. Check for obvious red flags, formulaic writing, maybe signs of overclaiming, basic statistical checks.
Before it even goes to human reviewers.
Right. It could potentially filter out some of the most obvious, low-quality stuff, freeing up human reviewers for the papers that deserve closer attention.
Interesting. Using the tool that exacerbates the problem to potentially help solve it.
It's one possibility being floated. Ultimately, though, the report really stresses this core idea.
What's that?
That science is not about papers.
It's not.
Not just about papers. It's about digging deep and finding the ultimate source of truth.
And that takes rigor.
Real rigorous methods, not just high volume.
Okay, so let's bring us back to our listener. Why should you, listening right now, care about all this nitty-gritty stuff about scientific publishing?
Well, because it directly impacts the information you encounter every single day.
The health advice you read online.
Exactly. The claims about new diets, treatments, lifestyle choices, and like we said, even the advice you might get from an AI chatbot.
Right.
It really highlights how challenging it is now to sift through everything and figure out what's actually reliable.
What's built on a solid foundation versus just noise.
Precisely. What's based on sound methods.
Yeah, it seems clear that in this age of just information overload,
Amplified by AI that can create content so easily.
discerning the good stuff from the formulaic stuff is getting harder and harder.
It's not just that there's more information, it's that a bigger chunk of it might lack that fundamental rigor we've been talking about.
And finding that ultimate source of truth that the report mentioned.
Yeah, figuring out if that study linking, say, coffee to some health outcome is really solid or just statistical chance.
It requires more from us, doesn't it? More critical thinking.
Definitely. And maybe a better understanding of the methods.
Yeah.
How was this knowledge actually generated? Are the claims justified?
Which leads to maybe a provocative thought for you to consider. In this world that seems increasingly flooded with these template studies, these correlations, how crucial is it for you personally to develop the skills to look past the headline?
To really evaluate the information.
Yeah, to understand how reliable knowledge gets built instead of just taking findings at face value.
And how important might a solid grasp of the fundamentals, maybe even the math behind data analysis and AI become?
As a tool for navigating this.
Yeah, as an essential tool for you to separate genuine insight from all that noise.
Well, speaking of fundamentals and rigor, one of our sources today, the Zaiku group,
Right.
they have a division called the Quantum Formalism Academy.
Yeah, and as noted in the source material, QF Academy, their focus is on making advanced mathematics more accessible.
For who?
Particularly for people working in these cutting-edge tech fields like AI, machine learning, quantum computing.
Okay.
And their goal is really to help professionals deepen that mathematical understanding, get a real edge, which seems, incredibly relevant given what we've just discussed.
About flawed analysis and the need for rigor.
Exactly, especially when dealing with complex data.
And the source actually mentioned that top technical folks from places like Meta, Google, OpenAI.
They're learners there.
Yeah, seeking to master things like topology, higher geometry, advanced math concepts.
Wow. Stuff that's becoming really important for understanding complex data, advanced algorithms.
Right. The idea is they're aiming to be in that top tier, the top 1% in their fields, by building that deep mathematical foundation.
It really speaks to that point, doesn't it? That to really operate at the cutting edge or even just critically evaluate the work.
You need that deeper grasp.
Increasingly, yeah. A grasp of the underlying principles, the mathematical rigor.
So if you're interested in maybe exploring that, building that deeper mathematical foundation, whether it's for AI or just sharpening your ability to evaluate information in this complex world,
It could give you that edge we talked about.
you can check out quantumformalism.academy. They've got details on their courses there.
Definitely one way to build those critical skills.
Well, thanks for joining us for this deep dive today.
Yeah, lots to think about.
We certainly hope it gave you a lot to chew on.